I'm running out of time tonight. It's getting a little bit past my bedtime, so I'm going to cheat a little bit on the big pot of soup problem. Newton's law of cooling. I'm just going to assume that you've read the whole problem and you know what you need to do. Newton's law of cooling. It says again that the rate of change of the temperature is proportional to the difference between the current temperature and the surrounding temperature. Okay, so given that, we're going to solve this differential equation. I'm not going to walk you through that. You can see my other two videos on how to walk through that. But eventually what you want to do is you want to get to this equation right here. This y of t equals 5 plus 95 e to the kt. Excuse me. So after getting to there, then you can answer the question, how long before closing time should the soup be ready so that Jim could put it in the fridge and leave on time? So again, I'll just leave this right here for you so you can get a screenshot of that, and then scoot on over here. And let's see here. Oh, this was to find our k, and we found our k. So basically all this work that leads up to this point right here, even finding our k, storing that in our calculator, gets us to here. So the actual work for the problem is very simple. Once we get to this equation, you just, we're trying to find when is the soup going to be ready, and the soup's going to be ready when the y, or the temperature, is 20. That's what the 20 comes from. And then, so we're just trying to figure out what t is. Subtracting 5 from both sides, dividing by 95. And then taking the log of both sides, we get log of 15 over 95 divided by k, which is what we have stored. That's our value for t. So that's how long from when it started at 100 degrees it's going to take before he's able to actually put that soup into the refrigerator. And there you go. So again, we have, and where's my red? We took my red. We're going to have to go with, oh, it's hiding over there. So anyway, right there is the answer. 33.773 minutes before closing. Okay, there you go. That was only 2.5 minutes.